Okay, so this is the contingency table question. And again, this is, it's 12%, 12 points out of 100 usually, somewhere around there on the test. So it's a fairly large chunk that you get all in one sitting. Do you have a strategy here? Do you remember the strategy that I gave you for attacking these 4 questions? You want to talk about it a little bit, or you want to just jump into it?
All I remember was the subtract the overlap.
Oh, all right. Well, do you remember that we're building ratios?
Yes, I
Okay,
do
that's
remember
good.
that. And then I turned mine into percents. Was
Yep.
I supposed to do that?
Making them percents, right? So you go from a fraction to a percent. That's important. Do you remember the advice about do the denominators first? And one of the reasons I suggest that is because in this set of questions, 3 of the denominators are the same and 1 of them is different. So you could either go with the 3 that are the same. You could try to find the one that's different. How do you find the one that's different? What's the key word?
I think it was if, right?
So if or given are the key words that indicate conditional probability. And conditional probability means we're not looking at the whole table. So can you see which question has if in it?
It's the third one.
Third one, right here. Okay. So that tells me 2 things right away. Number 1, that's the only one of these that's conditional, which means the others have the denominator of 366. So I'm just going to go ahead and fill those in. And how would you use the words to tell what's the denominator of this one, which is different? What's your strategy for that?
So we need the total amount of people that failed their drug test, right?
Right, because if they failed their drug test means I'm not interested in these people, and that's my strategy, is to block out the things that are not concerning me here. So yes, the total here should be 130, right? So you're halfway done with the problem. Now we just need to go back through and we need to work on all the numerators. Okay. What's the numerator if we're picking someone who's male?
$94.
Okay. Because that's how many males there are. The top number is the number of people that represent who we're looking for. So I'm looking for males. I want all the males. It's 94 of them. Okay. What about someone who failed their drug test and was a female?
Well, I got 328, but I have a hard time with these ones.
Mhm.
I think I got it right though.
Okay. I'm looking for someone who failed their drug test and was a female.
Is it the 198?
Almost. That's closer. Emily, I think you confused the or and started bringing multiple groups in, but this is just one group of people. There's a number on the board that represents this.
270.
No, I don't want all the females. I just want the females who failed their drug tests.
Is it 204?
Nope,
It's 74.
74. I want the females who failed the drug test.
Oh, okay.
Female failed drug test. Boom, that's it. There's only one group of those. I don't want the females who didn't fail the drug test. I don't want males who failed the drug test. I just want this group right here. Okay, now remember when we're analyzing this one, we're blocking out this bottom part. So if they failed their drug test, that's the row I'm looking at. And so who am I choosing here?
Females,
So that's
74.
or same top number, right? It's really important to block out that bottom part with your hand because you don't want to get sucked into these numbers.
I'm not understanding how I keep confusing that and keep adding them together because I think it's been every problem that we've done so far with that.
Well, the only one where we bring in multiple groups, at least unless, I mean, I guess if there was a question of where the categories, I mean, there were some questions I gave you on Wednesday where it was like over $20,000 and that included multiple groups. But in general, you'll notice that these three numerators are all just a single number out of the table. It's like you're trying to find the box that matches. But the one that's different, that's more challenging is the or, because the or is the one where you have to bring in multiple people. Because again, if you're standing at the door and letting people in and there's an or statement about the dress code, then there's multiple reasons I could let somebody in.
Right.
Okay, drug test or male. Failed the drug test. Oh, didn't fail the drug test or male. So again, we can do this using adding and then the subtracting, adding the totals and then subtracting the overlap, or we can just pick individual groups.
Would it be, it will be 94.
Okay.
You said that didn't fail the drug test. Okay, got 94 plus. Is it 94 plus 236?
Okay, that's halfway there. But now we have to account for the fact that there's overlap.
Would you? That's what I was getting confused.
What do we do to fix that?
You gotta subtract some.
Yep.
I'm trying to see which ones.
We'll look for the overlap.
Okay, so would you have to subtract the 198?
Nope, that's not overlap. Where's the overlap between this column and this row? You don't want it to be counted twice.
It's 38.
38's the overlap. So that's one way to get to the number. The other way is to go through and just identify who you want. You want these people, you want these people, you want these people, those three groups. That's the just finding the sum of those things program. Whichever way makes more sense to you. Okay, so a couple things about this type of question. Number one, start with the denominators. Hope that denominator talk helped clarify how to get the bottoms. Number two, when you're picking the tops, generally it's just one box and the hard one is the or, so maybe do that first or last, whichever one you prefer, but otherwise don't be adding different groups together. Just look for the specific group that I'm talking about. I'm talking about the males, that's the total males. I'm talking about failed their drug test in female, that's C2. I'm talking about females, if they failed the drug test, that's C2 again. This is the hard one. It's worth doing a lot of practice to get that right, because again, basically the math is easy because you just have to get the ratio set up and then do the percentage translation. The concept is the part that you need practice at. Okay, so I'm going to go ahead and do these calculations. You can check your percentage work. Those are rounded to whole percents. If you want 1/10%, that's what they would look like. Okay. Any questions about that contingency table? Again, if that's a weak spot, hit up the section 16 homework. And if you still need more practice, let me know. Okay, let's talk about the other one. Karen, this is the one that you were having trouble with, right? Okay, so the setup would look something like that. They'll probably provide you with the table so that you don't have to worry about it, but basically the table consists of people who have syndrome A, don't have syndrome A, and then people who test positive and people who test negative. Then the rest of it's just totals. And we're starting with 100,000 in the corner because that's our total. Okay, so the challenge here is to build the contingency table based on the percentages that are provided. Now, one of the the piece of advice I gave you about this is take a step of making sure you put both percentages down here. And what I mean by that is 5% is paired with another percentage and 98% is paired with another percentage. This is a connection to that normal distribution work we talked about, right? If we have a little, this is everybody, and we draw a line here, and this is 5%, then we can tell who's on the other side. Go ahead and help me fill that in. This one would be.
So with the 5%, you trying to find the total for us what is that? I can't even see that. Don't have it. I mean, has it. So would you say 5% times 100,000?
Yes, that's right. That's not what I'm putting here. I'm just trying to write out the fact that there's actually 4 percentages. When they give you 2 percentages, they're actually giving you 4 percentages. But I'll put down what you just said over here because that's important. We need 5% of 100,000, which is 5,000. But what's that other side?
95.
95%. Okay. You guys understand where that came from?
No.
It was not mentioned in the problem.
Right.
But if you look at this drawing and I say 5% is off to the right, how much is on the left?
It'll be
So do
90
you subtract with
100.
Right, because it's 100% is everybody. So if 5% of the population has it, then 95% of the population doesn't have it. And you see how that lines up with this row right here. I need to know what 95% of 100,000 is. That's the other side.
see that's why I couldn't do them problems, because that's a step that I didn't remember.
Yeah. Now I did finally get all the videos up from last week. I had a lot of problems getting things uploaded and transferred, but I did get the class videos up. So go back and watch those again if you want to see how we worked through it. So what's the other side of 98%?
2%.
2%. Right? Because these two things have to add up to 100%. So if I got 98% is the accuracy rate, then 2% is the inaccuracy rate. Okay, I've used this and I'm done with it. So I can put it to the side. Now I need to use my percentages of accuracy and inaccuracy to fill in these 4 here. This is the second part of the table. Remember, I start in the total column, then I go to this box, then I go to this box.
Mhm.
And I would definitely mark that in your notes so that you can remember that flow.
I have a question.
Yeah.
How did you get that 95,000? You said 95% times 100,000?
That's right.
Okay.
And 95%, of course, is 0.95 because 95% is 95 divided by 100.
Okay.
So it's not 95 times 100,000, it's 95%, which is 0.95. All 6 of these problems are the same in that they are percent of questions, where you just have to calculate the percent of this group that has it, tested positive, tested negative, whatever. Okay, so are these 5,000 people, should they test positive or negative?
They should test positive.
So why not just do this?
Because the test is only 98% accurate.
Right, so you're going to have some people who should have tested positive but actually tested negative. And the way we do that mathematically is the same. We take 98% and we multiply it by our total, which is 5,000 in this case, because we have 5,000 people who have the syndrome. So that's 4,900 people who should test positive.
Then what you subtract to get the negative, you subtract that from 5,000.
That's one way to do it. I prefer to do all of these the same way, which is 2% of.
Well, yeah,
Right.
but you don't get paid till Friday.
It's the same process. Now you're welcome to do the subtraction as your second part, because yes, these have to add up to 5,000. So if you know this number, you can subtract to find this number. The thing that worries me about that is if you made a mistake in this part, you're not going to catch it by subtracting. Okay, go ahead and do 98 and 2% on this one, and then check that they add up to 95,000.
Okay, wait a minute. You got the 2% because them the number of people that tested negative. I'm a little confused.
No, 98% accuracy. What does that
Okay,
mean?
you get
It means
that-
98% of the time you get the right answer.
right.
So what about the other time?
It's 2%. You get the wrong answer, negative.
Exactly, that's right. No, it's not always. I don't want you to think negative that way, because
Okay.
sometimes negative is the right answer, right?
Okay.
Like if you don't have the disease, you should test negative. That's the right answer.
Right. Okay.
So that's why I'm using right and wrong instead of positive and negative.
Okay.
So go ahead and do 98% and try to get them in the right box. Think about where they would go. If it was 100% accurate, what would it look like? And then try to do the calculation both ways as percentages and add it up to see if it adds up to 95,000. That's a nice reinforcement check. Okay, let me ask you a question. Should the people who don't have syndrome A test positive? Should people who don't have this syndrome test positive?
Oh, no.
No. So we would expect the majority of people in that group to test negative, right? So this is what it should look like, but it's not 100% accurate. But that tells you where the majority group goes, right?
Right.
Cool. So then what am I going to put in this box here?
The 93,100.
Good. 93,100. All right. And then how do I figure out this other number? I mean, I know I can subtract, but what's another way to do it?
Multiply it.
Multiply by.
Is it 98?
Well, we use 98% here. So if
Oh,
we use
well, 2%.
2%. So we want 2% of this group. And if I test it, I should be able to add these together and get back to 95,000. Does that work?
Okay. My issue, what I keep doing, when you say 2%, so that's 0.2.
No.
That's
No,
what
it's
I'm
not.
doing.
Yep. Remember that it's nice to be able to just stick the decimal in the right place, but if you're not doing it correctly, don't take that shortcut. Just do divided by 100. What is 2 divided by 100? It's not 0.2.
Okay, so it's 0.
0.02.
Right. So that's the multiplier then. Equals 0.02 times 95,000. 1,900.
Okay.
Okay.
Okay, that's all right.
Now, those are the kind of errors that you want to kind of self-identify and say, well, I got to come up with a better way of doing it. Because if I'm doing it this kind of short way, but sometimes I get it right and sometimes I get it wrong, it's not good enough. You want to have a way that's guaranteed to get you to the right place. So that's just dividing by 100. All right, now let's bring these together. This last one is just a sum game. Boom, boom. And so that's, I don't know, maybe 4 points, 5 points, and then you're supposed to put it together to answer this conditional question. So the reason I say it's a conditional question is because what word do you see that tells you that? It's a conditional probability.
So we would just need the people that have syndrome A over the people that tested negative for it.
It sounds pretty good. What's the key word that tells you this
Given.
is conditional? Given. That's right. So this key word here, given, is the one that really draws you in to say, oh, wait, this is conditional. So you got to break out your black marker. Boom. Nope, that's wrong. Given that they tested negative, I'm getting rid of everything but tested negative. Okay. Very easy to, especially if the clause is at the end of the question, not at the beginning, to get sucked into the beginning and start thinking, no, focus on the given, focus on the clause that follows from the given or the if. It's not the thing that comes first, it's the thing that's conditional, given that they tested negative. Okay, I'm only focusing on negative tests, right? So what's my total then? If I'm only focusing on negative tests?
So it would be 100 over 93,200.
Right. So the total is 93,200. And then I get the 100 because I'm interested in people who have syndrome A. That's the 100 people on top there. So there's my conditional probability. And of course, I could turn that into a percentage. This is the decimal. It's a very small percentage. It's very unlikely that this would happen, which is good news. I mean, it is not impossible. That's bad news, but it's not very likely to happen. In a medical context, pregnancy aside, this is a very problematic area because it's not likely to happen at all, but you also generally don't have systems in place to double check those things. You don't ask people to come back and get retested if they test negative because it's good news and 99.9% chance they got the right answer that they should have gotten. It's just scary in the case of, something like HIV, where you don't think you have it because you got a negative test, but then in fact you were really incredibly unlucky and you got a false negative, means you actually have it, right? The reason that pregnancy is kind of not an issue is because it was not going to take a lot of time for you to figure out it was a false negative, right? You still have symptoms, you still have morning sickness, you still don't have your period, and you're like, okay, well, I got a negative test, but I don't believe it. So you go and you get another test, and that's how you find out that it was a false negative. And you may know people that have had false negatives before. That it happens. Okay, so again, I think this has got some interesting application for the time we're living in with the coronavirus pandemic. You've got testing. I mean, it's just a huge question, huge problem in terms of, are these tests accurate or not? We don't see anybody talking about definitive accuracy rates for different tests. So that's a challenge as we go forward, and we're trying to keep our community safe and understand whether we can reopen the economy and reopen things, and having good testing is an important part of that. Okay. Just because I haven't given any space for it, do you guys have any other mathematical questions about the coronavirus that have occurred to you as you're walking along the road of life?
Do
I can
we
send
know
you
the
some.
accuracy rate for the testing?
No, that's what I just said. I haven't seen any of those numbers. I don't know what they are. My impression is that the antibody tests are less accurate than the stick it up your nose test. But even the stick it up your nose test depends on, there's some real physical things that matter, like how far did they stick it up? How long did they leave it there? What was the viral load in that area? That's part of the reason they're going up your nose that far, is because that's more accurate to do that than to just rub it around the inside of your nose. That's much less painful, but you're not necessarily going to get the virus up there. So that's part of why that's such a painful test. But no, I don't know any accuracy rates for that. My sister was sick in March and was just had a very hard time, had a lot of symptoms that were like coronavirus. She got tested 7 times and she came back negative every time. And they determined that she had bacterial pneumonia. Just a coincidence that happened at the same time as everything else went down. But, they treated her like a coronavirus patient when she was in the hospital. But 7 tests, the reason they asked for 7 tests is because nobody could believe it. Generally, keep getting negative test results. You're like, well, okay, yes, that is really a negative test result. But the part of the people not believing those results was this unsureness about how good these tests are and whether we're doing it right. So, and that's part of why the newness of the disease is difficult. Okay, so like I said, if you're interested more in data and numbers around the coronavirus, there's a good ProPublica article that talks about what are some of the things that you would look at, because there's a lot of numbers around coronavirus. There's positive cases, there's number of tests, there's the ratio, the positive test rate, there's the number of deaths. So there's lots of different things that you could be looking at to try to determine whether your state is doing good or not, or your community is doing good, or your country or whatever. And there's a lot of very opinionated people that have ideas about what's right, what's wrong, and the way we should be doing it. And it's a very difficult time for people on the ground. And so I wish that there was some definitive number that you could look at and you would know, but the reality is that it's quite complicated. And anybody who says it's simple, I don't think is being honest about it.